So here's the round I intend to make the clamp part out of. That'll clamp onto the tailstock of the lathe. This is a scale drawing, and you can see that if I centered this on the stock and I wanted to cut this whole piece out, I'd need a much larger diameter piece of aluminum. What I'm proposing to do is to save material, is to bias this down, put it in a 4-jaw chuck and turn it off center. So what I'm going to do is I'm going to glue this to the face of this and bore this hole out very precisely so that it'll match the diameter, the outer diameter of the tailstock. If you're wondering what I'm talking about there, that clamp goes around here on the tailstock, and that will catch the end of the rule of the digital readout. These two pieces, when I finish them, I am going to mill out little slots in here that will pinch down on one end of that. Currently, this end over here. So with the template on, I use the center to press against the back piece here, and then just tighten the chucks in place to hold it. And you'll notice it's quite a bit off center. I've got to make sure that there's enough of this jaw in the chuck to be safe, and that it's not going to have an interrupted hit with the cross slide. So I'm going to come back, I'm going to back off the center here. Tight. And make sure that we're all good. I'll give a final tap into place. So, yeah, my concern, that's really close. Okay, but it probably wouldn't be safe if any less of the jaw was in. It's about halfway, so probably wouldn't be safe anyways. I thought about reversing one of the jaws, which I still could. The only problem is if I reverse this jaw, I might still be able to get it to float. That might be safer. I'm going to do that. So now I've reversed the jaw. I think that's a lot safer. I prefer none of the jaws to stick out at all. It's never a really good idea if you can avoid it, because there's less material supported by the chuck itself. So I'm ready to bore. This is off center. We're going to go fairly slowly. And so another mistake I made, so I had to redo this. I used this originally behind it so that I could have it parallel, so I could bore a straight hole through this, which makes great sense, except for one little problem. Can't get this out after you tighten it down because it's stuck between the jaws, which is one of its purposes, so you can't actually throw it at you. But had to put parallels instead, because otherwise when I bored through I would have hit this. So had to reset, use these parallels, pop them out, and we'll get ready to go. So this material is fairly thick, so I will be using lube, mostly to keep the drill bits from sticking, but I am going to go fairly slow here also. I am going to be going right now 300 RPM with a 1/4 inch drill. I can't push too hard because there's nothing back in the part. Just over 3/4. This might be pushing it. We'll see how much force is needed. I can always return to boring. Or go to boring, I should say. Looks like it's cutting well. I just sharpened this guy. And I'm pleased that the chips are about even. So now we're going to go to boring. I've sped back up to 300 RPM, and I'm going to go in with a feed rate of 9 thousandths a revolution. That might be a bit aggressive. We will give it a shot, see how we do. 50,000th depth of cut. Except for throwing crap everywhere, the chip breaker's working pretty well. So this is going to take quite a while. Even with the high feed rate. We got to ultimately end up at a little over 2 inches. Have to go back and look at the number, but for now at 1.1. We're getting really close. So I switched to the finishing an aluminum cutter. The last one was for steel. So I've also changed the feed, slowed the feed rate down a little bit. Just taking 3/1000ths off to put us really close. I want to lock this in. So. Says we're right on. Here's a way to test this theory. Wow. Like a glove all the way through.
So next up is getting this guy, the fixture, onto the rotary table. First get the rotary table aligned on the mill. Get this guy on the rotary table and aligned with a spindle. Get this guy and put it on, ready to cut and align vertically the way I want. And clamp it down with the hold down piece. I'm still debating whether or not this part, this section that sticks out, is going to need some additional support. It's fairly thick, so I think if I take small cuts, it'll be all right, even though I'm going to be taking, 3/4 of an inch cut. I was originally thinking about putting tape under the whole thing to help support it besides this clamp. Still on the fence about that. I'm going to think about that some more. Anyways, let's head over to the mill and show you how I'm going to align this.
Alright, so the first step is getting this guy aligned with the quill and centering my DRO on the very center of the rotary table. So I've made a tool which I purchased this on eBay. It is a Morse taper 3 to 3/8 24 threaded insert. This guy fits perfectly down the ground and board and ground center of this guy, and I've made this on the lathe a 1-inch diameter threaded attachment, and I've made several attachments. So what I'm going to do with this is, now that these two are together, I am going to mount this inside this 1-inch end mill holder that has also been ground. First I'll mount this in the quill, and then I will drop this down and insert this, and leaving this loose, I will allow the Morse taper to center this on the quill. Then I'll tighten this down in place. So now we've got the 1-inch end mill holder, and I've lightly tightened these guys. This has the 1-inch adapter piece I made for alignment, and this Morse taper 3, now I am going to lower the quill to center the rotary table, and I'm going to lock it in place, and then I am going to tighten the supports on the rotary table. That should get it aligned, centered with the quill. So now that I've tightened both sets of mounting bolts, I will go up to my DRO and I will zero my X and Y axes. Now my quill should be centered right over the table. So next step is to align my template with center here, and I made this smaller 1-inch insert that'll fit inside the recess on the bottom. I made these fairly close, and get these guys lined up, screw them down, bring you back. So next, I set the 0 to match the indicator on my rotary table so I can start at 0, because next part I'm going to do is I'm going to place the part on here. I'm going to line it up so that the peak is over here, and then what I'm going to do is clamp it down with this guy, which is it's indexed. So first I got this guy centered at the high point on this disc by rotating this back and forth to make sure my probe was dead center. My x-axis is set to 0, and then I'm going to rotate this side to side, I know you can't see it, and go for the peak. So we have this guy lined vertically now, and be good to crank this guy down, hold it in place, and then we can machine around the periphery here and make our profile. The only hole that's a little bit critical is the one that is dead vertical off of this, centered on this upper section. I will be drilling and boring that hole after I have finished doing the profile. So I almost made a really big mistake, and I'm glad I caught myself. So I drew tangent lines, not tangent lines, I drew radii out to the points where I wanted my vertical piece to stick out, and it was exactly 60 degrees. But for a 1/2 inch cutter, it's not going to end up right here. I'd cut in to that edge, and I'd lose a 1/4 inch off a side, which would be no good. So instead, I went back and used the tangent radius function on my CAD software, and I placed a 1/2 inch cutter at each one of these locations here so that I could figure out what this angle is, and it turns out it's about 70 degrees instead of 60 degrees. If I'd gone 60 degrees, it would have cut in right at the base here, so that would have been a big mistake, and I would have wasted this part. So we're shooting for 1.625 on the radius, will be the final radius all the way around to this point. The problem is it's going to take bigger and bigger bites as I go around, so I probably won't be able to go too far because it's going to eat more and more material. So in hindsight, it might have made sense to bandsaw off some of the excess material. I just don't have a very good bandsaw, so I decided not to do it. But it's a lot of material to remove. So another way to do it is to get this set to 0 and lock it down, which it is, and then come over my 0.75 plus another 1/4 for my cutter thickness, and then come straight into the center radius, which is what I'm going to do. So then I went into my final radius and did a once around from 325 to 35, which is 1/2 degree off, but that cleaned up this whole inside part, got my radius in the right spot. Now we can just bore the hole and we should be nearly done with this part. I mean, I'm going to have to still drill and tap on several spots for the set screws that are going to hold it in place, but we'll be mostly done. So now I'm going to whip this around and orient it back to 0 degrees, and I am going to lock it off, And then I've got to put a drill chuck in here. You come out the appropriate distance and drill my 3/4 inch hole, which I think what I'm going to do for ease sake is I'm going to start by drilling, and then I am going to use an end mill, 3/4 end mill, and just come straight down, one that can plunge, of course. See how that works. So we're going to start with the center drill. And then we're going to move to 1/4 inch. So here goes nothing. Here's a 3/4 inch end mill. I've reduced the speed to about 800 RPM. Again, I use my quill DRO to set my depth so that I'll know when I'm through. All right, and we're done. That worked quite well. And since a milling cutter cuts rather, differently than a drill bit, the hole should be round and perpendicular. Shouldn't be any wandering going on, especially considering how stiff a 3/4 inch end mill is. So now I can pop this part off of here and deburr it, and we'll be ready for the final drilling and tapping for set screws. So here's the final part. Oop, looked like I didn't go, just left a little bit of lip on the one part there, so I'm going to have to take that off with a file, but here's the final part. I think it turned out really nicely. And it's, I made this thick this way, beefy, because I want it to be stiff, because this is connecting to a DRO and we really don't want any flexion, because then I'll get wrong readings. So let me deburr this and we'll move on to the next part. So this next part is the base, and this part mounts on the top of the tailstock like this. The tailstock would be right here, and the digital readout would mount here, the actual electronic part of it. This part sits just behind on one side of the tailstock and screwed through into the tailstock itself. So it's kind of challenging. The order of operations is kind of critical, because this 30-degree side is important, and this is a 12.5-degree side, which is also important, and getting the parts so that I can actually hold it in the vise and mill these parts is kind of challenging. I've taken the approach on this where I am going to hold the part in the vise at an angle rather than nod the head or tilt the head either side on the mill itself. Nodding being this direction, tilting being this direction. Angles can be achieved that way just as well, just as easily, but since I have multiple operations, I'd have to take the vise off and on so I could retram it each time or set the new angle, and that sounded like a bigger pain in the butt than it was worth if I can somehow manage to hold this part reasonably in the vise and get both angles. In order to do that, I have to get the order of operations correct. So what I plan on doing is this 12.5-degree angle, I don't have to remove all this other material. I can just cut with an end mill the 12.5-degree part down to its total final depth, and then flip it over, do the 30-degree, drill the hole, come back and remove the excess material. And I think I can hold that just fine doing that. I'll have a flat reference spot to get this rotated around to remove this material here. In order to calculate how far over to get my zero, what I've done is I've taken the part and rotated it in CAD so that the part I'm cutting is dead vertical, which is 12.5 degrees off of vertical. If this is vertical, 12.5 degrees lean to that side. And what I intend to do is I intend to just measure over the distance I need to. And I notice I've got the part turned incorrectly here. So I actually need to fix that. This needs to be rotated 90. I just need to make sure I got enough material to hold on to. So I marked out the line, got my zero set by the corner of the end mill, just barely touching the material. I think I'm just on the other side of the line, so I can move in just a tiny bit. I decided to use layout so that I could get really close because of the angles involved, it's really hard to get my geometrical bearings. So we're going to give this a shot, and let me put this guy in gear, and we're going to take one light pass. Got to set my speed up, 2,000 RPM, and let's just come in a tiny amount, so 2,000ths. Looks really good. Yeah, I think that'll work. So we need to go in a total depth-wise 0.499. So let's see if we can do 50 thousandths passes. So this is the tool I use to get this 12.5 degree angle, and you see it's got markings along this side. This part rotates as ground and precision ground, so it's really nice. And I set it to 12 degrees, 30 minutes. It's got a vernier on it for minutes as well, in increments of, it looks like 10 minutes. So anyways, I set it to 12 degrees, 30 minutes, and took my hole to depth to this corner right here, and then when I come straight across I will clean up the rest of the material. But now I've got my angle, which is going to be hard to do later with other material removed. So the next setup is to do the 30 degree portion milled off the top part here, and the way I did it is I used my 30, 60, 90 triangles on top of some parallels, slid them in, and then held them and tapped down, and then pre-tightened this, and then checked to see that there wasn't any slop. So no slop. So this should be set. These sides are still perpendicular, so it should all be good. My concern, of course, is that this guy is going to move a little. Now I could have used that previous tool, except I also have to drill some holes through here, so that's going to be a problem. What I am going to do is I'm going to mill this direction, back and forth this way, so as to push into the jaws of the vise rather than this way where it might want to push down. So that's my hopes, that it won't move. Otherwise I will have screwed the part and we'll have to consider something else. Sorry about the fan noise, but it's just before Thanksgiving and it's 93 degrees out here in Southern California. Wow. Anyways, I am about to cut this guy, the 30 degree bevel on here, and some of this material here, there would only be a 1/4 inch. This is almost 3/4, and only a 1/4 inch would be left if I had finished the milling on this other side, and you can see there wouldn't be a lot of material to bite onto like there is now. So that's a plus. I know the depth I need to go down to, and I put a rough line just to tell when I should be getting about there. What I did was in CAD was, again, rotated the part so that the 30 degree side would be dead vertical, and then continued out where the material is, and I need to go down 0.541. CAD's really handy. Of course you could do this all with geometry, but I chose to do with CAD. Alright, let's get on with the milling. So these cuts are going to progressively take off more material, but let's make the first cut something easy like 25, 30 thousandths. more cuts, and I decided to do a sanity check and see if the part had moved, and it appears not, at least at this time. One more thing for besides the sanity check is if the part moves mid-cut, this line will not be straight because it'll tilt down and it'll cut less over here than it did initially if it's pushed down. So that's another sanity check. Keep an eye on this. I've got it cranked pretty tight, so, and I'm going to take small bites, so we'll see how we go. So things are still looking good. We're almost to the line that I drew, and we're 40 thousandths away depth of cut. So I'm taking lighter slices. I started with 50 thousandths, then I went to 33 thousandths, and then 25 thousandths. So now I'm going to do 20. So it's a really good sign when you're cutting down to depth, and as you reach depth, the cutter just kisses the line I scribed on the surface plate. So that's a really good sign. So now we need to drill some holes, and then we can move on to milling off the extra material off this side, and this part will be done. So the trick I'm using to find the edges, these are two, relative to this perpendicular, these are two sloped edges. So trying to find this edge, first I deburred it after I machine it, and I want to find the dead center between these two edges. So I used a trick with this electronic readout indicator, and here's what I did. I set my Z to 0, brought this down very lightly until it just went on like that. Then what I did was, after I set my 0, I brought it down a little bit, took it over to the side, and went half a thousandth or so past where it was touching the top surface, and then came back and let it just find that edge, and it seemed to work pretty well. Half a thousand, come back and touch, and that's a very good approximation, I believe, for this corner. I mean, if it's damaged, then not so much, but I'm going to try it and see how it works. I think I did all right. So we've already drilled one of the holes. I'll bring you back for drilling the second. I'm using a countersink first, and I'm going in a little bit deeper so that I can use it to chamfer at the same time. And 1/8 inch. These are going to be metric screws because the DRO itself uses metric. So we're getting a little bit of chip welding here, so I had to do this before. We are going many times the depth relative to the diameter of the bit. Probably like on the order of 8 to 10 times, so that's a bit challenging. So clean it off a little bit. It always seems to have the most trouble right as it's about to go through. All right, we're done. So next we can rotate this part and mill off the extra material on the one side. So the only thing here that I need is depth because I've pre-cut this other slot. I do need to find myself into that corner at the end, but I just need to find the Z0 because I know how deep to go. And there it is, just starting to touch. Okay, I need to go down 0.487. So I'm going to take like 50 thousandths bites, but only cut around the edges. Show you a little bit, then bring you back. This is my roughing finishing end mill. And another 50. surface finish. So I got a bunch more passes. I'll bring you back when I'm closer or done. So we're shooting for the last pass, heading to 487 thousandths, which is where we are now. Last pass was about 5,000. So here's the finished part. See, this is down to 1/4 inch now, and this guy will sit on the tailstock like this, with the DRO mounted like this. So I almost forgot countersinking the holes in the back for these screws that I've got that are metric, and getting the depth right so they just barely protrude through, because if they go too deeply, they will stop the slide on the DRO from moving. So I did a 3/8 hole to give me plenty of clearance in case I need to add washers or something, but I think I've tuned this in pretty well. And I can drill a couple holes back here for the mounting holes, and then I really am done. So this guy here and this guy over here are the mounting holes for this part. And what I did was I drilled them the tap drill size. That way when I put this up against the tailstock, I can use the drill for the tap drill and just use it as a guide to drill. So I figured that'd be easier, instant template. Then I can drill these out to the body size after. So the first step in the final assembly is to put the rule on the mounting plate. So it's maybe hard to do on camera, but we'll give it a shot. The fit is really close. Oh, that was lucky. We got one started. Okay, there's one. And here is two. Don't want to put this one in last, because if you do, you'll be reaching behind trying to put it on. That'll be a big pain. So okay, still moves. Next step is to mount this guy to the tailstock. Which is just these two screws right here. So the next step is going to be to put this guy on, and it's such a tight fit that in order to get it on, I actually have to put a little Vactra on it. So otherwise it just sticks. It's a really tight fit. There we are. And once you get on, there is no slop. Okay. Next is the clamshell. So the reason the clamshell rotates is so all these parts could orient without, making it challenging. I made all the tolerances so close that this is a really tight fit. Okay, so there we are in. So, lock this guy in and this guy in. And finally, snug these guys. And there we go. We are good to go. So, I just need to get a battery in here. I'll bring you right back. So here's the DRO in action. If I'm already in that far and I need to set my 0, I can set my 0. Go in another 1/2 inch. Right there. And I can control my depth. It's pretty nice. And that's pretty much it. Thanks for watching. Hope you liked it. See you next time.